Hello friends, welcome back to Optimizer Step, where we teach the concepts of AI and ML step by step. So here is something strange. A machine learning model can't actually read your photo, your marks, or your YouTube comment. It doesn't look at your selfie and think nice lighting. It literally can't say it. So the question arises, then how come AI understands anything at all? It turns everything, text, images, sound, all of it into numbers, arranged into shapes called as scalars, vectors, matrices, and tensors. That's the language of AI. And that's how AI sees the world. And today, we are going to learn this language of AI.
We can see a student, a house, a photo, or a sentence, but a machine learning model cannot see this. A machine learning model only sees numbers. So basically, in the real world, we have different kind of data, right? So it can be a house data, a student's data, a photo, or a comment, or a video, or an audio, right? This is what in the normal world we can observe these things, right? But a machine cannot observe these things directly. So what it does? So there is a workaround. We convert these data into numbers. Okay. So a student's details becomes features. Okay. A photo becomes pixels. Okay. So a student, okay, and text becomes numerical representation. Right. Now, once the world becomes numbers, Once the world becomes numbers, the model can compare, calculate, learn patterns, and finally make predictions. So this transformation is very important for model to understand the context of the data, okay, and then to observe the patterns and make predictions. So the final point being that the machine cannot observe the real world. It only observes the numerical world. Okay, so let's say we have students data. Okay, since students data is converted to features, now these features can look something like this: 85 and 90. This 85 and 90 can be numbers. All right, now the machine can understand the context of the data. Okay, this context, the context over here is these are the marks, and the maximum marks, let's say, is 100 and 100. So obviously the student has passed the exam. So this is how the machine understands the real world. Now think of these four terms: scalars, vectors, matrix, and tensors as a ladder. So we have already discussed in the previous video that a scalar is a single number, one number. Okay, a vector is a list of numbers. Vector is a list of numbers, and a matrix is a table of numbers. Matrix is a table of numbers, and a tensor is numbers arranged in even more dimensions. So the maximum dimension of a matrix is 2. So how does a matrix looks like? So basically it will look something like this. So let's say 1, 2, 3, 4, 5, and 6. Okay, so there are two rows, 1 and 2, and there are three columns, 1, 2, and 3. So this is a 2 by 3 matrix. Okay, so this is a matrix. A vector will look something like this. For example, over here, 85, 90, and 78. So this is a vector. Okay, so this vector is usually represented like this. Fine. Okay, and scalar obviously is a single number, so it will not have any shape. Tensors is a kind of matrix stacked together. So we'll discuss about it in the next slides. Okay, now so this is the organizational structure of numbers for machine to understand. Okay, so this is how we organize the numbers so that the machine can understand the context of the data. Now, obviously, this is the most easiest one, scalar being a single number. So for example, a price of 9.99, this is also a scalar. Temperature 36.5 is also a scalar. Exam score of 87 is a scalar. 3-bedroom house, the 3 being a scalar. Okay, so let's say you have a vector 85 and 90. Okay, a very simple basic vector. Now individually these are scalars, 85 and 90, these are scalars, but combined together this becomes a vector. Very simple. Now vector is a list of numbers. Okay, now let's suppose there is a class in which there are 10 students. Now out of these 10 students I have one student whose name is Vishal. Fine. Now this student has the age of 18, attendance of 85, 78 marks in maths, and study hours is 4. Excuse me. The study hours is 4. Now, how do we represent this student to a machine? How do we represent this? Now, this can be represented in a format called as a vector. Okay. Now, over here, 18, 85, 78, and 4. These are the values fed into the vector. Okay, now this vector can be fed to the machine. This vector can be fed into the machine so that it understands this single student. Okay, so this vector represents a single student. So a vector can represent one real world object using many numbers. So over here, we are representing a student with 4 values. We are representing a student with 4 values. So in ML language, one input example or one row of data is often a vector. Okay. In the last slide, we discussed about a single student. Now let's say I want to represent 4 students of the same class. Okay, how would we do that? Okay, but we know that a vector has only a single row, right? So the last vector was 18, 85, 78, and 4, right? So now this is a vector representing the student Vishal. Let's say I want to represent 4 students at a stretch. Now, how do we do that? So we stack these individual vectors. So the first one becomes a vector, the second one becomes another vector, the third one becomes another vector, and the fourth one becomes another vector. Now, if we stack these together, so how do we do that? How do we stack them together? So something like this, let's see. So we'll stack them like this: 18, 85, 78, and 4. Next 17, 90, 82, and 5. Next 19, 70, 60, and 2. I hope you get the point, right? So these are the vectors stacked upon each other. This is a matrix. This is a matrix. Very important concept, and especially for AI and ML, this is the most important concept in AI and ML. We'll get into the depths of matrix later, but I just wanted you to be very comfortable with matrix. Okay, now a matrix is a table of numbers. Okay, now rows are examples, columns are features. What does this statement mean? Rows are examples, basically meaning that rows are students, and these are their properties. So 18, 85, 78, 4. This is the property of the student that we discussed, Vishal. Okay, so rows are examples, columns are features. So this 18, 85, 78, and 4 are the features of a single student. Very clear? Okay. Each row is one student and each column is age, attendance, maths, marks, or study hours. Okay. So in machine learning, your training data usually looks like a matrix. So whenever you hear training data, think many examples, many features arranged as a table. Now, let us talk about a word that scares many students. Tensors. But tensor is nothing very complex. See, once if you understood matrix, you have understood 80% of tensors. Okay, a tensor is simply numbers with more dimensions. Now, what do I mean by dimensions? Let's say I'll take a very simple example. Okay, we have already discussed the shape of a matrix. So let's say you have a matrix of 2 by 2. Okay, so basically 2 rows and 2 columns. So let's say I have a matrix 1, 2, 3, 4. Very simple, easy. Now, let's say I have another matrix 5, 6, again 2 by 2, 7 and 8. And again, I have one more matrix, let's say 9, 10, 11, and 12. Now, so these are three individual matrices. Now, what if I stack these matrices one over the other? So basically, if I have 1, 2, 3, 4, this one matrix, and on top of it, you have 5, 6, 7, 8, and on top of it, you have 9, 10, 11, 12. Okay, so one matrix over the other. Okay, so this is a tensor, but you might have a doubt. But okay, I understood the what is the shape and how does a tensor look like. But what is the need of stacking these numbers? Okay, where is it used? Basically, where is tensors used? So matrix we understood. Okay, number of students, their features, that's fine. Now, but where do we use these tensors? And tensors is mostly used for images and videos. Okay, let's say, so a color image is a great example of tensors. Okay, it has height, width, and colors. Okay, now height and width and color. So we understood, okay, color image has height, width, and channels, or you can also call it as colors. Okay, so you said that it is a tensor. Yes. Now, what is this 224 by 224 by 3? So basically, imagine 224 by 224 matrix. Okay, so basically this 224 represents pixel height, pixel width, and the colors. Okay, so let's say you have there are three layers: red layer, green layer, and blue layer. Okay, each of this layer will have 224 by 224 matrix. Each of this layer has a 224 by 224 matrix, and each of them will be stacked one on top of the other like a sandwich. Okay, that this tensor is that simple. Deep learning uses tensors heavily because images, videos, batches of data naturally have more dimensions. Okay, so this is where tensors is used mostly. Now let us connect everything using a simple student performance prediction example. So raw details: age 18, okay, attendance is 85, math marks is 78, and study hours are 4. Okay, to us this looks like a student profile. To us this looks like a simple student profile. Now to the model this becomes a vector. To the model this becomes a vector. The model takes the vector and predicts something like pass or fail. So this vector goes inside the model. Okay, this vector goes inside the model. It learns the pattern. So this is not the only value obviously we are going to pass to the model. Okay, there are going to be many other values which will have the output already given to the model. Okay, now the model will observe those values and look at the output of those values, and then it will look at this vector and make a prediction that whether the student is going to pass or fail. Okay, so the model never saw the student, it only saw a vector of numbers. So this is how a number is converted into a logical output. Now the same idea applies to images as well. Okay. Now, the last time we discussed about 224 by 224 by 3. Okay. Since there was that was a color image, we had red, green, and blue layers. Okay. There are going to be 3 layers, one stacked over the other. Now, if it is a black and white image, the channel value becomes 1. Okay, the channel value, the color value becomes 1. So basically, there is only a single matrix of 224 by 224. Clear? So 0 can, a black and white image can be seen as a matrix of pixel values. 0 can represent black, 0 can represent black, and 255 can represent white. Values in between represent different shades of gray. Okay, a color image goes one step further. It has red, green, and blue layers already discussed. So a color image will have red, green, and blue layers, but whereas a black and white image will only have a single layer, only a single layer, with the values in that 224 by 224 matrix lying between 0 and 255. Okay, so basically it will look something like this: 0, 100, 200, something of that sort, and the shape will be 224 by 224. Okay, depending on the clarity, obviously. Okay, if it's of higher quality, these values will increase, the number of pixels will increase, but we are talking about the general shape. Okay, so the 224 by 224 matrix without any channels represents a black and white image. Now, for a color image, there are 3 layers: red, green, and blue. So, whenever you see a cat or a dog image, okay, you see a cat and a dog, but a model sees a block of numbers. Okay, so that's the difference between you seeing an image and a model seeing an image. Now here is a tiny Python preview using a NumPy library. So this Python library called as NumPy is used for numerical calculations. Okay, do not worry about memorizing the code. Okay, just notice the shapes of scalars, vectors, matrices, and tensors. So let's get started. So first of all, I'm going to import the library as np. So a scalar is one value. So let's say that value is 10. A vector is one dimensional array. So 85, 90, 72, let's say. And a matrix is a two-dimensional array. Matrix is np.array. So 85, 90, 72, 88, 73, 83, 91. And a tensor can be something like zeros with the shape 224 by 224 by 3. It can have any values, but for simplicity sake, we are taking zeros. np dot zeros. Okay, so this is a scalar, this is a vector, this is a matrix, and this is a tensor. Okay, so let's look at the shape of scalar, vector, matrix, and tensor. So first of all, to get the shape of scalar, so you can look at the error because it's an int object. So basically it's only a single value. It will not have any shape. Very clear. Now let's look at the shape of vector 3. Okay. Since this vector has 3 features, the shape of the vector is 3. Now let's look at the shape of matrix. It's 3 by 3. So basically 3 rows and 3 columns. Okay. Now let's look at the shape of 224 by 224 by 3. Okay, so this is how usually matrix, tensors, vectors, and scalars look like. Shape matters in AI and ML because when we are going to train a model, this will make a lot of sense. Okay, but right now, what I can tell you is that the shape of the data, the shape of uh, the input, okay, this will become very, very important when you train a model. Okay, we will train a model, then I will explain this concept even in more depth. But right now, remember this, that a scalar has no shape. Basically, it's a single number. Okay, a vector has only a single row. Okay, it will only have a single row, and there are going to be the features. These are individual features. Okay, now a matrix is a 3 by 3. It can be anything, a row by column. Okay, this is a matrix. Okay, now a tensor is a high dimensional matrix. Basically, one matrix stacked over the other. Okay, this is a very layman's term, but to make you feel comfortable with the concept, I'm telling you this. If your model complains, check before blaming Python. This is very, very true, and you will appreciate this statement when you are going to train the models. Okay, now, okay. So a quick recap of what we have learned today. The scalar is a single number. Vector is one object, many numbers. Matrix, many object, many features. Okay, and a tensor is a higher dimensional numbers. So basically, this tensors is used for images, videos, and in deep learning models. So in the next video, we are going to talk about vector operations for AI and ML. Now, in that, we are going to discuss about vector addition, vector scaling, vector dot product, and similarity. So the usage of vector operations you can observe in data representation, and you might heard the word embeddings used usually in RAG pipelines. So their embeddings in behind embeddings, vector operations happen. And there is also a concept of dimensionality reduction. You decrease the uh, data's dimensionality basically to make a model simple and efficient. So these are the concepts where vector operations are used. So tomorrow or in the next video, we are going to discuss about vector operations. So today we have basically understood the data and its shapes. Next, we are going to learn what we can do with vectors. See you in the next video. If you have any doubts, please feel free to drop a comment. I'll always answer to your comments. Goodbye.